Right. In this case, we are going to focus on our implicit function, the application of the implicit function from our April 2023 exams. We have given the implicit function determine dy dx. This is our implicit function that we are given. And from here, we are asked to find or to determine dy dx. Remember, an implicit function is the one that we can't make y or x the subject. We are given the variable of y and x taken as variables in that matter. So what we need is to find the derivative of y with respect to x. And I mentioned that whenever you're dealing with an implicit function, a function of y, if you are given a function of y, whenever you're to determine a derivative with respect to x, you determine the derivative of that function with respect to y times dy dx. So that is the condition. So what you're going to do in this case, because you are given this, you can just try to cross multiply so that you can just separate these two. So that is we're going to have at the end 1 times this side. We are going to obtain 9 minus x squared is equal to 1 multiplies this side, which is going to be y minus x to the exponent of 3. So if we check here, there's an exponent of 3. Actually, we're supposed to expand, to be honest. You're supposed to expand, which is another method that you can work with. I will try to work it in another class so that we understand that we're actually supposed to expand in this case, but it was going to take us a lot of balls. Look at the exponent of 3, it's a higher exponent, but if it was 2, it was going to be easier like that. All right. So what is the condition that we can do instead of expanding? Remember, the concept is to find the derivative of y with respect to x. So we are going to differentiate both sides, y with respect to x. So if we differentiate 9 with respect to x, that's a 0 in this case. We move on to x. With respect to x, we're going to have minus 2x because this is a function of x. Okay, let us consider this. It's a function that consists of y and x as the variables. Remember from our chain rule, if you are given an exponent like this, you differentiate the bracket, the outer bracket, considering the exponent of 3 in this case. This is what you're going to do. You're going to differentiate considering the exponent 3. You drop the exponent 3, you remain with y minus x like this. Then what you do is that you differentiate the inner part of the bracket, everything inside the bracket. So that is, we are going to differentiate everything inside the bracket. All right, let's differentiate y. We are differentiating y with respect to x. Remember what I said about this concept to say that whenever you are dealing with a function of x, a function of y, you differentiate that function times dy dx because we're talking about y in this case. So this y here, we are going to differentiate it, which is a 1 times dy dx. That's how we work with an implicit function. You do the same thing on this x. You differentiate x, which is minus 1, but this one is for x, so you're not going to multiply by any derivative in this case. So remember the concept of our function of function. Sorry, this is supposed to be the exponent, of course, you're supposed to subtract 1. This is supposed to be exponent of 2. You differentiate the bracket, you drop the exponent, 3 times 1, which is 3. You write the bracket as it is, you subtract 1, then you differentiate what is inside of the bracket. So this is the derivative of what was inside of our bracket here. So that is how we can end up with the dy dx in this case. So what we need here is to make dy dx the subject because we are supposed to have dy dx. So what can we do? We can divide by this bracket, both sides, because this is a multiplication. So you can divide by the whole of this part on the other side of the equation. So this is going to be minus 2x everything over 3 into y minus x to the exponent of 2, which is equal to 1 times dy dx. That was going to be just dy dx minus 1. Remember, what we need is to remain with the dy dx in this case. So we're going to transpose minus 1 to the other side so that it can be a positive in this case. So that means we are going to have minus 2x over 3 into y minus x squared. We take this 1 to this side, it is going to add. So this one is going to give us our dy dx, of which we can just rewrite our dy dx in a way that is understandable. That is, we can write it as dy dx is equal to, we write this part, we can even start with a positive. So it's going to be 1 minus this part of 2x. So it's going to be 2x over 3 into y minus x squared. The simplification does not even matter already. You are done. The simplification there does not even matter. So this is how you can have your expression as of which you can even expand and have another. The answers will be just a little bit different, but representing the same thing. I shall talk about that one later on. 2.42, determine the equation of the tangent. Take note, we are talking about the tangent to the graph at 0.13. What is the idea of a tangent to the graph? We know that if a tangent is being drawn, so this tangent, sorry, before we talk about this, is taken at 0.13. So the idea of a tangent is that if a tangent is taken, where am I taking 1.3? I'm still having 1.3 in mind. All right, so this is 2.42, sorry. So if you are given a curve like this and you've got a tangent, the idea is that at this point of tangents, the point of tangents in this case, the curve and the tangent will be at the same point, which is at 0.13. And at the same point, these two, they have the same gradient. That is the concept. They have the same gradient, whereby we are saying the gradient of the tangent is going to be equal to the gradient of the function. Our function is this one, which is equal to dy dx at that point. So m is equal to dy dx at the given point. All right, at the given point, and our given point is 1, 3. Why are we talking about m? Because we're talking about a tangent, which is a straight line, whereby we know that its equation is given in the form of y is equal to mx plus c, whereby this m here is the one that we are talking about that is equal to what? To dy dx at the given point. So to find m, we're simply going to substitute the point that we have. Remember, a point gives us the value of x and the value of y, meaning to say they are saying where there is x here, we are having a 1. So in place of x, we substitute a 1. Where there is y, we substitute a 3. Where there is x, we substitute a 1. So we're going to simplify this from our dy dx, because we are saying dy dx is the one that is representing our m, which is our gradient. So if we substitute 1 in place of x, in place of y, we substitute a 3. We're going to obtain our gradient, which is m as 5/6. So m being our gradient, in this case, m being the expression for dy dx at the point 1, 3, is going now to give us the equation at the given point 1, 3. Our equation, like I said, is given as y is equal to mx plus c. We have the value of m, which is our gradient of the line, which is 5/6 x plus the constant in this case. So in order for us to have the value of c, which is our constant, we are supposed to substitute the point, because I said at this point, it's a point of tangents, which is the same point for the curve and the graph and the tangent. So here they are at the same point and they have the same gradient at that point. So you are going to substitute the value of x, which is 1, and the value of y here, which is 3. We find the value of c. So this one was going to give us 3 is equal to 5/6 plus c. We transpose this to the other side. So we're going to obtain 3 minus 5/6. 3 minus 5/6, which is going to be something like 13/6, which is going to give us the value of c. So therefore, our equation now of the tangent is going to be given as y is equal to 5/6. That is 5/6 in this case, this one that we are having here. So it's going to be 5/6x plus the constant c, our constant, which is 13/6. So this is our equation, which is in the form of y is equal to mx plus c. That is the gradient intercept form. That is how we could have obtained the equation of our tangent in this case. So what was important in this question was understanding the gradient concept. What happens to the tangent and the function at the point of tangents, at the point where the tangent meet the curve? They will be at the same point, and at the same time, the tangent and that function will be having the same gradient. So the gradient of expression from the function is represented by dy dx. So this dy dx is representing what we refer to as the gradient expression, is the expression which gives us gradient at any point that you are given. That's why you'll be given at this point 1, 3, at this point, so that you determine the gradient that is at the given what? At the given point. So that is the whole idea about these implicit functions. Sometimes they can end up having a condition whereby you continue from that dy dx. It's not only from implicit function, it can be from any derivative. The derivative part is that dy dx represents the gradient expression. That is the derivative part. So it's not like it's only found on the implicit function only. It can be on any question as long as it's a derivative question. All right, so that's what we had, guys, from this particular question. Let's continue to revise. Prepare yourselves for the exams which are ahead of time.